1.1, we are talking about points, lines, and planes. What were they talking about? Yesterday you did your vocab. What were they talking about when they meant, or they talked about undefined terms? What does that mean? They don't have a definition, right? Okay, they don't have a definition. We just kind of understand what they mean. So a point is just a dot, right? For lack of a better word, it's just a dot. How is it labeled? How do I label a point? A, B, C, just a letter, right? It will always be a capital letter. Okay? Points are always capital. So when you do your assignment and you're telling me the answer is point F, do you need to make sure you put a capital F in the box? Yes, otherwise it'll count it wrong because it is wrong. Okay? The other thing to know about a point is, does it have any size? Does it take up space? No. It takes up no space at all. Okay? Our next undefined term is a line. What do you know about a line? It is one-dimensional. And it goes on for how long? Forever. In how many directions? 2. Okay, so it goes on forever in 2 directions. Did anybody catch how many points it takes to make a line? 2. Good. Okay, it takes 2 points to make a line. Has to be more than 1, because if there's only 1, I don't know what direction to make it go. Does that make sense? I mean, I can draw a line through this point, but I can sit there and I can turn it and move it, and there's no distinguishable direction that it should be going. Okay. How would I name that line? What would that line be named? Line BC. Is there another name for it? Call it something else. I could call it line CB. Same thing, right? Why does it not matter which order I put those in? Because no matter what, it's going on forever, right? In both directions, okay? So it's irrelevant which way we write that. You will also see many times on lines, they will put an italicized lowercase letter at one end of that, or at one arrow on that line. Can I use that letter to name the line? Have you guys ever used like line L or line S before? Okay, I could also call this line L. It will always be lowercase and it will always be italicized. Okay, so there's 3 different names for that same line. The next one we have there is a plane, and the planes are going to get kind of hard to draw. Just do your best. I like to just draw a rectangle of some sort. Try to make it leaning so it looks semi-3-dimensional. Okay, but it's not too big of a deal. Your artwork isn't what you're getting graded on. Anybody catch how many points it takes to make a plane? 3. It actually only takes 3. Now, you would think 4 because it's got the 4 corners, right? Okay, but it actually only takes 3. So I could have point A, point B, and point C. Notice I made all my points capital letters because they are points. But it takes 3 points to make a plane. So I could call this plane ABC. I could call it ACB, BCA. Whatever order you want to name those points in, that's fine. They might also put a capital italicized letter in here, in which case I could call that plane M. Good. I could call that plane M if I wanted to. Okay. The next term we have, first of all, what does the word co mean? Like if we had co-captains or something like that. Like two, multiple, right? Okay, together, the same, equal to each other, things like that would be what co means. So if I have collinear points, the word linear means line, right? So I have multiple points that are what? On the same line. So that term you wrote down, collinear, means they are on the same line. Jason, name 2 points that are on the same line up there? So they're collinear. Okay. What about A and B down here? Even though there's no line drawn? I agree with you, Tegan. Those are collinear. There does not have to be a line there to be collinear. Okay? The rule is between any 2 points, there exists exactly one line. Okay? So no matter where I put the points at, I can always draw a line there if I wanted to. Okay? So I could do A down here and C up here. I could draw a line there. A and C are collinear. Okay? I could put a point here on the bottom of the floor and back there on the water spout for the fire alarms. They're collinear. I could draw a line between them if I wanted to. Okay? So keep that in mind. 2 points, they're always collinear. Now, are A, B, and C collinear? No. They're not all on the same line. Okay? The next one, coplanar points. What would that mean? They're on the same plane. A, B, and C, are they coplanar? Yeah. Okay. We're good there. Okay. So, taking a look at example 1. Okay, we'll just start right here and go down the row. Question number 1 says, give 2 other names for line PQ in example 1. Line PQ. Give me one other name. We'll start. Okay, I could call it line N. Paul? Line PQ. That's another name for that. Line QP, exactly. Okay, moving on. What about plane R? Another name for plane R. V is just a point. So if you're using points, how many do you need for a plane? 3. So add a couple more there. Okay, VST. One more. William? One more name for plane R. VSP. Okay. What about VSQ? Why? Yeah, Q's not on the plane. Okay, good. Okay, and onto the back row back there. Okay. Name 3 points that are collinear in that diagram. SPT, perfect. Okay, and moving across the row, name 4 points that are coplanar. PTSV, good. And again, not Q because that is not on the plane, correct? Okay. On to page 5. So if undefined terms do not have a specific definition, that means that defined terms do. Okay. So, the first one we're looking at there, they talk about a line there, which was undefined. But the next one down, we have a line segment. Which, what do we know about a line segment? It has how many endpoints? 2 endpoints. Okay, and since it has 2 endpoints, unlike a line, does it have a measurable length? Yeah. Yes. Yeah, I could measure that. And those endpoints are going to be labeled as points, so they're capital letters. Okay, where are we at here? How would you name that segment? What would you name that segment? Close. It's not a line though, right? Segment AB. There you go. And is there another name for it? Oh. Okay. BA. Okay. It doesn't matter what order I put those in because they're both endpoints, right? Okay. I don't think I'm missing anything there for segment. The next one is array. What do you know about array? Anybody? Has 1 endpoint and does what after that? Goes on forever. How many points do you need to make a array? 2. Why? Yeah, so I know what direction to make it go, right? If I don't have 2 points, I don't know what direction I'm going in. Okay, so I have CD. How would I name this array? Ray CD. Why not ray DC? The endpoint is C, right? Notice the endpoint is C, so when I write this, C is the endpoint. Okay. Now I do always get a little confusion here when I do this. Is this EF or FE? It is FE. Your endpoint will always go first. Okay. I also get this. They say, well, the ray's going left, so I'm going to draw my arrow that way. Don't do that, right? Okay, don't do that. Because now I'm saying the endpoint's at E. Is that accurate? No. My endpoint is at F. Okay, so no matter what way your ray is facing, when you write it, that arrow is always going left to right. Okay. The last thing we have there are what are called opposite rays. Which, just based on the definition, are 2 rays doing what? Going opposite directions. Okay, so I have, let's just use point A again, and B, and over here we'll use point C. So my opposite rays are AC and AB. To be opposite rays, they have to share a common endpoint. Do they? Yes, my endpoint is what point? A. Okay, if I were to say AC and CB, yeah, those are 2 rays going in different directions, but they're not opposite rays because they don't start in the same place. Does that make sense? They overlap each other. Okay, so these would be opposite rays. If I have opposite rays, what do they form? A line. 2 opposite rays together are going to form a line. Okay. All right, taking a look here, example 2. Where are we at here? Let's go back to Jason, actually. Let's go back there. Give us another name for segment GH, please. HG, segment HG. Okay. And across the aisle, name all rays with endpoint J. Yes. JG, JF, JH, and JE. Good. Okay. And Dylan, then which of these rays are opposite rays? JH. But JH is opposite with which other ray? Shows a common endpoint but goes the opposite direction. JH and what goes opposite JH? JG. Take a look there. JH and JG. See the difference? So then give me the other pair also. How about JF? JF is opposite of JE. Good. Okay. Flipping the page, we're over on page 6 now. Okay, just talking a little bit about intersection. When I have two lines that intersect with each other, what do they form, or what is their intersection called? What's right here? It's a point. They intersect at a point. I couldn't find a good way to say that really. Okay, but two lines intersect at a single point. Okay. If I have a line and a plane, which I'll do my best to draw this for you, but no promises. I have a line, it's going at a plane, it touches right there, and it goes through it. That also intersects at one point, right? It'd be like if I took the marker and I was going through the board as the plane, it's going to go through right there. Okay? If I have two planes, that's a little bit different. Keep in mind that planes go on forever in every direction, right? So both of these planes continually go up and down forever. What is formed by where they intersect? It could be. It doesn't have to be, but it could be a 90-degree angle. What would this be? Would they intersect? Over here I made a point. When two planes intersect each other, I make a line. Okay, when two planes intersect, they form a line. Okay, I'm not going to spend any more time on example 3 and 4 than that. Just keep in mind those things as you're working through your homework. Okay, the last example I want to look at is, like usual, last one's the most difficult. Example 5. It says the diagram shows a molecule of sulfur hexafluoride, the most potent greenhouse gas in the world. They want us to name two different planes that contain line R. So first you got to find line R, and then remember that to be a plane, it takes 3 points. So we're looking for planes. They don't actually have them drawn, but we're looking for planes that have line R on them. When you think you have one, raise your hand and let me know. There are 2 of them. Go ahead. Think you got one? FBA. FBA, which would be that vertical one, right? Can everybody imagine that vertical plane there? Okay, and that would have line R basically going across the front of it, right? Okay. There's one more that line R is on. Go ahead, Paul. E, B, C, which is actually, oh, E, B. Okay, so EBC is your other vertical one, right? Is it on that or is it going through it? Line R. Line R is going through it. So that would end up being perpendicular. We want one that line R is on. But you're right, it is going through it on that one. Jersey, you got the other one? F, B, C. That's the same one? That's the same one you gave me first. Yeah, but it's still the same vertical plane. FBE, there we go. FBE would be that horizontal plane. It's the only horizontal plane there, and line R would lie on top of it. Okay. Any major questions before I give you a chance to work on some problems on your own? Okay. Yeah, go ahead.
Why wouldn't like FBG work?
FBG would. FBG would be the horizontal plane. It'd be the same as FBE. It'd be the exact same plane. Okay? All right. You have the rest of the class to work on your assignment.